So let's do it quickly. A parallel plate capacitor with air between the plates has a capacitance of 8 pF. So the capacitance when there is air between plates, then is generally written as C0. So how much? 8 pF. Now, what will be the capacitance if the distance between the plates is reduced by half, and then between them, the space between them is filled with a substance of dielectric constant 6. So let's describe it in form of diagrams. It will be easy that way. Suppose the distance between the plates of capacitor is d, and there is air between them. This is the capacitor. First, what do we do? What do we do first? We reduce the distance to half. So now new distance will be divided. Okay. So can you tell me what will be the new capacitor? 4 size is 16. Clear or not clear? Why 16? Because formula of capacitance of a parallel plate capacitor is epsilon 0 A by D. If D is half, double हो जाएगा. Clear or not clear? Sure. Okay. Inversely proportional. Okay. So now it's 16. Now what next? What next?
Space between them.
And now space between them is filled with dielectric substance. Okay, of how much? 6. K equal to 6. And here K equal to 6. So what will be the final capacitance? 96 pF. Yes or no?
Yes.
Cannot so much ready. 96 is clear. Why 96? K into C1. You know C0 nahi, because that was C0, but here this is K into C1. Clear? Okay, everybody. K into C1. So that's going to be 96. Okay. That's pretty good. Okay, let's go to number 8. No, sorry, 9. Number 9. 2.9 from the exercise. Explain what would happen if in the capacitor given in exercise 8, 3 mm thick mica sheet of dielectric constant 6 were inserted between the plates. Did you understand the question? So we have to take the capacitor of 2.8 and between the plates here, how much is the distance between plates in that question? 2.8? 3 mm thick, and we are also inserting a sheet of 3 mm. Aakhi space filled hai, isn't it?
Yes.
Yes or no?
Yes.
Okay. So then if we insert this kind of dielectric material with dielectric constant equal to 6, then we have to find out find current. Voltage, find current. Read it. Explain what would happen. Explain what would happen if this sheet is inserted in what? While the voltage supply remains connected. The big case first. We are inserting the sheet while the battery is still connected. Did you get that? Supply means battery. Yes or no?
Yes.
So if battery remains connected, what will remain constant? What will remain constant?
Voltage.
Yes or no?
Yes.
Sure.
Yes.
Everyone. So voltage kilo? 100. So voltage will still remain the same. So V dash equal to 100, same as V. Clear or not?
Yes.
That is, it will remain same or constant. Okay or not okay? Capacitance no होता है. What will happen to the capacitor? एक काम करो ना से V0 और V लग V dash. So this is C. What will be the new capacitor? What will be the new capacitor? Will it be K times?
Yes.
6 times. Is it? K 6 times. K C0 when you fill it completely. All right. Okay, so it will be K C0. K 6. What was C0? Do you have the answer of previous question with you? Okay, I am leaving that part to you. Whatever it is, okay, it will be 18 pm. After you out of there, whatever it is, okay, you can do it. Is this fine? 11.7. Okay, that one. There is a okay, no problem. Fine. What about charge though? Voltage will remain same. That's clear. Yes, no.
Yes.
Why is voltage same? Because battery is still connected. Capacitance will become 6 times. Then what do you think will happen to the charge store? Will charge store remain same? Will it increase? Will it decrease? What will happen? Increase. And become how many times? 6 times. So once again, simple idea. Q equal to CV. V is same means it's like Q proportional to C now because V is same. So Q is proportional to C. So if C becomes 6 times, Q should also become 6 times. Is that clear? Sure. Okay, so you can actually write this as 6Q0. Means whatever was the charge stored earlier, now there is more charge. Understood? Okay, પછી ફાઇન્ડ કરી લેજો ને આવડી જશે ને વેલ્યુ ખબર નહીં બુક માં તો કે દે લખ્યો છે કારણ કે આમાં એક્સપ્લેન એવું લખ્યું so what to explain just write it as voltage supply is connected the voltage for capacitor plates remains the same that is 100 volt new capacitance is C equal to this and new charge stored would be this that is 6 times open up okay ready ને સમજ પાક્કું ને okay fine then part B what's part B the sheet is inserted after supply or battery is disconnected okay so I'm already disconnected what will happen over there what will remain same and reason of that છે ને Q will be same that is same as Q0 okay આવું ન લખતા exam માં Q equal to Q0 એવું લખજો Q is equal to Q0 Q will remain same because the capacitor plates will be isolated પછી capacitance નું શું થાય what will be C will it be same as this capacitance નું શું થાય 6 will it be 6 C0 yes or no yes or no yes એમાં થાય ને why because the formula that we have derived C equal to KC0 that is not dependent on voltage and also not dependent on charge is that clear it will be true in every case so if this is completely filled see the 6 times there whether you connect the battery or not irrelevant understood yes or no
Yes.
okay so C will be same as here that is 6C0 then what will happen to the voltage it will
Decrease by
decrease by 6 correct
Yes.
or not correct
Yes.
absolutely sure
Yes.
why decrease by 6 because V is equal to Q by C but Q is same and C is getting multiplied by 6 so that's why V will go down by 6 that is it will be V0 by 6 or 100 by did you understand everything clear in this question now બધું યાદ રહેશે ને which one remains constant which one changes like that fine okay or not okay okay now let's talk about what happens if it's not completely filled barabar ne what happens if okay that's it ready what happens if it's not completely filled so there are two parts capacitor with dielectric slab partially filling space okay so what to do if it is partially filling the space not completely filling the space part A area of plates is divided or shared between dielectrics. So let's say these are the steps. Suppose suppose the distance between the plates is d, as you know, right? And if the dielectric material is in such a way that over here, this much area, a material with dielectric constant K1 is occupying, and let's say that part of the area is A1, and the remaining area, for example, all the way up here, is occupied by some other material, means other slab, okay, which is having dielectric constant K2. So area A1, area A2, K1 and K2. Clear or not? Area A1 and A2 and dielectric constants K1 and K2. Area કેવી રીતે ડિવાઇડ કર્યો? આ લાઈન ડિવાઇડ કરી હોય એવું લાગે. It's not like that. Think of it in 3D. The easiest way to understand is think of room here. આ બે plates. Okay. So suppose you would put a giant slab all the way, let's say from up to here, from ground up to here. And આમ check સુધી ઓલી બાજુ હટાડી દો. તો આ wall નો એરિયા હતો ને, ई અડધો ડિવાઇડ થયો ને, એક આટલું આ છે, પછી એની ઉપર બીજું છે. Can you imagine this? Yes. So the area of the plate has been shared, A1 here and A2 for the second one. Not paying. Okay, if I can draw it in 3D, I'll try. Let's see. Not absolutely sure I'll be able to draw it nicely, but I'll try. બે બુક ની વચ્ચે આ પડે વાંધો નહીં, જોઈએ ડ્રો કરીને સમજાવી દો, સમજાઈ જાય તો પછી કઈ બીજું જરૂર નથી. Did you understand? This is one upper slab. Okay, પછી એની નીચે અહીંયાથી આ બધું, below that it will be the lower one. Can you imagine this? Sure, like going between two books, this and this. Okay, so here read the title. This is where area of the plates is divided in 1 and 2. But distance is d for both. That is, our width je che e to same hai ne, અહીંયા ને. Make sense or not? Sure. Okay, so in this kind of situations, what to do? Okay, પહેલા આ વધારે ઈઝી છે, અને પછીનું થોડું. So here, if I want to find out how much is the capacitance of this whole thing, then I'm going to divide it into two parts. Listen to this. Suppose on this, I'll line you for first capacitor, I'll line you the second capacitor. Yes or no? Yes. And I'm going to cut it from. Then, if I take a point, let's say x here and y here, and if I take a point, let's say L here and M here, then do you realize that Vx and Vl are same, and Vy and Vm are? Why so? This is a plate. This is a plate. Yes or no? Yes. All points on the plate are at same potential. Yes or no? Yes. In a metal plate. Yes. Alright? On a metal, all points are at same potential. So Vx and Vl same potential. Vy and Vm same potential. So अब ये difference आवे. For the first part, the voltage is Vx minus Vy, and for the second part, the voltage is Vl minus Vm. Do you agree that both are going to be equal? Yes. This is वच्चे ने बोला भाई equal है तो subtract करो तो same हो जाओ से. Yes or no? Yes. Absolutely sure. Yes. So this is a proof that what this means is if you cut it from here, then these two capacitors are going to be in what? बोलता नहीं. વોલ્ટેજ છે માં ઇક્વલ આવે, પેરેલલ માં આવે ને. યસ ઓર નો? શ્યોર. નથી સમજાણું? અહીંથી કટ કરી નાખો તો આ બે જે છે, that is cut, that is separate. Okay, not like throw it away. If you see them separately, then both of them are in parallel to each other. Clear? Yes. કારણ કે કે ખબર પડી આ વોલ્ટેજ સેમ આવે. That's only possible in parallel. Got it? અચ્છા, તો નવી સર્કિટ પડી. So this is first capacitor, here is second capacitor. Okay, this is completely filled with K2, this is completely filled with K1. And this has area A1, this has area A2, but the distance between the plates is D for both of them. Did you get that? No. Sure. So parallel में तो C equivalent कैसे find? C1 plus C2. Yes or no? Yes or no?
Yes.
Okay, C1. Look at this capacitor. Look at that capacitor. What is its area? A1. Okay, what is its distance between plates?
D.
But it is completely filled with K1. So into K1 convert है ना? Yes or no?
Yes.
What formula? C equal to KC0. So without this slab, it would have been epsilon 0 A1 by D. But because there is a slab completely filling this one now, that's why K1 into epsilon 0 A1 by D. Similarly, look at second one. Suppose a slab no હોય તો second નો શું આવે capacitance? Epsilon 0 A2 by D. Yes or no?
Yes.
But we know that it is completely filled with this second slab. And એટલું કટ કરી નાખો એટલે એટલું તો completely filled જ કહેવાય ને. So that's why multiplied by. Did you get that? अच्छा कई common છે? So take it one. So C is equal to epsilon 0 by D. K1 A1 plus K2 A2. If there are more, you can just keep adding. Easy. Suppose formula નો યાદ રાખો તો કઈ વાંધો નહીં એટલું તો યાદ રહે છે ને કે these two are in parallel. Area divide થાય ને આમ એટલે parallel માં આવી જાય. Got it? Sure. પછી આરામથી મોબાઈલ મૂકી દો તો પૂરું થઈ જાય. Fine. Okay. પછી તો parallel ની formula તમને આવડે છે. Easy enough to understand. By second. આમાં શું કર્યું? Distance same. Area divide. હવે મને so it is distance between plates is divided or shared between the electric materials. Distance between plates. Now, can you imagine how it's going to be in the room first of all? Suppose this is one plate and that one plate. So, આ બે plate નું distance હોય એને share કરવાનું બે material માં કેવી રીતે? It's like you put one here and then you put the other one from here to here. Got it?
Yes.
The thicknesses may be same or may not be same. એનાથી કઈ ફરક નથી પડતો. You understand that? So, let me draw it first of all in the most efficient but boring way. Suppose this is D1 and let's say the remaining D. Okay, it is D2. See, I can write D minus D1, but I don't want to do that. I just write D2. Clear? Clear or not?
Yes.
So do you realize that here both of them will have same area A? કયો area જોવાનો હોય એ કહો. Suppose you put a big slab here, then this whole slab will be touching that plate. Yes or no? So આખો plate નો area A છે ને એ બધો આનો area થઈ જશે. Got it? Clear or not? આની પહેલા કેવું હતું? નીચેનું જ cover કરે. So area was not complete. A1 A2 એવું છે. હવે આમાં કેવું થાય? It will take the whole area of the plate, so it will be A. But then it will not go all the way till distance D. So it will be D1 and then next would be D2. Got it? એટલે આવો diagram થઈ ગયો. So area is A for both of them. Clear? Area is going to be A for both of them. એ કયો area છે? અહીંયા જે plate હોય એ rectangle છે. So now you see these are not going to be in parallel like it was here. So we have to do something. Yeah, they are going to be in series. Right? You might have guessed it. It's okay. Normally most people are able to guess that one. But કેવી રીતે છે? Let's talk about that. Suppose we take point on the left plate P, point here Q, and point here let's say R. Then obviously VP minus VR is equal to VP minus VQ and plus VQ minus VR. Yes or no?
Yes.
Now the થાય ને? No થાય?
Yes.
Sure. Everyone understood that?
Yes.
So if I treat this part as one capacitor if I treat this part as one capacitor, right? Then the capacitance, the voltage for that will be Vp minus Vq. So that would be V1. First capacitor. Where is the first capacitor? This is the first capacitor. Got it? Our blocks in order. That's first capacitor. Because it's going to be having or storing some charges and all that. Then the second one, K2. That will be the second capacitor. So its voltage would be Vq minus Vr. So that is V2. So we have total voltage between the two plates, which is V, which is equal to V1 plus V. This would definitely mean they are in series. Okay, so they are like in series. Achha, so equivalent circuit draw karna hai. This is the first one with width d1 or distance d1 between plate. Here the material is K2. Direct. And here is D2 and here is K2. Clear or not? Okay, sure. Okay, the areas are both A. So in series 1 by C is equal to 1 by C1 plus 1 by C2. Okay. So what is 1 by C1, or first of all 1 by epsilon 0 A by D1. Okay. But that's not filled with air. This is filled with dielectric material. So here K1 આવશે ને C1 is equal to K1 into epsilon 0 A by 2. Yes, no.
Yes.
K denominator માં સમજ પડી ને? Okay, because C is in the denominator. Similarly, okay, anything common? 1 upon epsilon 0 A is common. And then you have D1 by K1 plus D2 by K2. Now without taking LCM, I'll just flip it over and take reciprocal of it. So C is equal to epsilon 0 A divided by D1 by K1 plus D2 by K2. I don't want to take LCM. This is a very convenient form to use. If there are more, keep adding here. If there are more, you can keep adding. Got it? No, because we are not talking about any other area, but the one of that surface which is parallel to the plate. For example, if you could assume that we fill all this up to half of the room, right? Then the area that is facing the plate is A. So, અહીંયાથી thickness આમ increase કરીએ તો it always change not that. Did you get that? We are not talking about total surface area. We are only talking about the area that is facing the plate. Clear? Sure? So it's not this area, but the area on this side. That's right. Okay, so that's the formula for dividing the distance. What if both are divided? એવા sums આવે. You have to be a little bit careful over there. એવા પછી પહેલા practice કરતી વખતે એના માટે કંઈ અલગ ફોર્મ્યુલા બનાવવાની જરૂર નથી. It will work up from the basics only. એના માટે કરવા જશો તો યાદ જ નહીં રહે, complicated. Right? These two are clear. I personally suggest that you try to remember this one. Why? Because although all this process is not impossible if you have values, but it will definitely save your time. Parallel જેવું નથી. Parallel માં તો કેવું છે, ખાલી add જ કરવાનું હોય. So you can just do it in one step and get through. પણ આમાં થોડીક તો વાર લાગે, તમે આમ reciprocal કરશો ને પાછું આમ કરશો. So if you want to save time, you can remember this one. કારણ કે આમાં ખાલી value મૂકો એટલે answer આવી જશે. Clear? Okay? All right. Now there is one question regarding this topic given in your book. આ theory book માં નથી આવી. તો બધાને કહું છું, exams જે પેટર્ન ની હોય એ રીતે કરવાનું. ફોર એક્ઝામ્પલ ડેરિવેશન્સ કેવું હોય આ એક પણ તમારે કરવાની જરૂર નથી, યાદ રાખવાની જરૂર નથી. બટ સ્ટીલ આઈ સજેસ્ટ that you learn how to derive. કારણ કે એક્ઝામ માં કઈ તમને બધું ફોર્મ્યુલા યાદ નહીં રહે. જેડબલ્યુ કે ઇવન ગુડ સેટ માં આવા ક્વેશ્ચન આવી શકે. ઓલરાઈટ, કારણ કે આમ જો તો સમ આવો આપેલો છે બુક, થિયરી નથી, સમ છે. લેટ્સ સોલ્વ ધેટ ક્વેશ્ચન. Okay, it is example. एक बाकी है example આપણે કરવાનું. Which one? 2.8. D કર્યું તો બધા મેં તો નહોતું કર્યું. Make sure you didn't write A and A twice. Like D. મળ્યો કે નહીં? K ની વેલ્યુ મટીરીયલ ની પ્રોપર્ટી હોય. મટીરીયલ ની ડેન્સિટી કોની પર ડિપેન્ડ કરે? કોઈની ઉપર ન કરે ને. એના જેવું છે. K is a property of material. In fact, we are going to talk about that section very soon. See, example 2.8. A slab of material of dielectric constant K has the same area as the plate of a parallel plate capacitor, but has a thickness of 3 by 4D. Did you understand that? Kari jo draw શું કીધું? Has same area as plates, but not the whole thickness. I mean, not the complete distance is covered, right? What's the distance between plates? D. Clear? The slab is only up to this point. Okay, so what's in the remaining D by 4? Air. Clear? This is air. And this is some dielectric material with K equal to, happy the line? Nothing happy. So K equal to K. Now, first thing that we will have to identify is it like the first type where area is shared, or is it the second type where the distance is divided or distributed? Distance. Barabar the second. Okay, sure. Then to use that formula, we have to identify what is D1, what is D2, what is K1, K2, and all that. So what is D1? First material, 3D by 4. Okay, K1 is K. Clear or not clear? Yes. Second material, air. Distance D by 4. Got it? Air is ultimately a material, isn't it? Yes. Okay, where second material for dielectric constant for air is 1. Okay, dielectric constant for air is 1. Think of it like this. This is a capacitor. It is already filled with air. Its capacitance is C, 0. Yes or no? Suppose now you fill it with air. It means you are going to multiply with some dielectric constant. If it's already filled with air and you multiply with K, which is the dielectric constant of that material, so શું multiply થાય? One is multiply થાય ને કે બીજું કઈ થઈ જાય? Got it? Another way to understand. Do you remember E is equal to E0 by K? When we say that E is the electric field in a material, so inside air the electric field will be same as vacuum, nearly. That's why if these are equal, then K for air has to be 1. Got it? To be very frank, it's not exact 1, and the air is going to check. For vacuum, it is exact 1. For air, it will be more like 1.0001 or something. Not very, but we can take it approximately as 1. No problem. Sure. So K to 1. समझ में आई कि नहीं? Yes. Okay, everyone. Yes. D2 D by 4 K to 1. So C equal to sorry. Epsilon 0 A upon denominator में D1 upon this. It is 3D by 4K. Clear? 3D by 4K is clear? Plus. Okay, I got sir. D by 4 and divided by K2, but K2 is समझाणु ने? Okay. Anything common in the denominator? Epsilon 0 A तो छे. Denominator में D common. Yes. Maybe I will take by 4 common. Okay. What's the meaning? 3 by K. So if I take LCM, I get 3 plus K upon K. Clear? Yes. Maths में आवाज़ रहते हैं ना? वो एक साथ एक्टिवेट हो. Right? Okay. Now, what is epsilon 0 A upon D? C0. क्या वो C0 था? C0 that is when nothing was inserted. When nothing was inserted, at that time it was C0. So you can write this as therefore C equals C0 Okay, 4 will go to numerator. K will also go to numerator. Correct or not? Okay, 4C0 into K upon 3 plus K. Did you understand? Okay, just by using appropriate values in that formula, we have been able to do it. Clear? And now the bad news. This method is not valid according to the textbook because this formula has not been derived. એટલે તમે આવી રીતે સોલ્યુશન લખશો તો માર્ક મળશે નહીં. Understood? Okay, so just by using the formula you can get the answer obviously. But book માં તો આવું કંઈ છે જ નહીં. હવે તો નામે નથી લીધું કે આવી ફોર્મ્યુલા થાય. So what to do? We have to do by basics. એટલે એવું કંઈ tough નથી. I'm not saying it's going to be difficult or anything. But you'll have to use a little bit of the skills of electric field and all that. See, I'm not drawing the diagram again. Here says I'm using it. If the electric field here is E0, means in air it is E0, then here it will be E. Then E will be equal to E0 by K. Yes or no? Inside the dielectric. Is this sentence clear to you? Sure or not sure? Now, if you want to find capacitance, what's the plan? Q upon V. You got it? Sure. So that's what we'll try to do. That is what we will try to do. Okay, but what we can do is that whether, do we know whether we are inserting this after removing the battery or something? You know that? We are inserting plate or something after removing the battery. You said it means we can take it either way. Capacitance ગમે તેમ કરો same જ આવવાનું. Whether you have the battery connected or you have already removed the battery. So we'll do it by removing the battery. Clear? Why? Because if you remove the battery, charge remains same. And by the charge find on tension. Okay? So Q upon. Now we have to find V. We have to find V. Right? At the moment I'm just writing this step, over here so that you pay attention. So let's try to find out V. If we know about electric field, we can find V easily. Do you remember V equal to ED for capacitor? Yes or no? અહીંયા કેટલો potential difference થાય between P point and Q point? Raise your hand if you understood this. This is only between P point and Q point. Check સુધી નહીં. Between P and Q. No cover ready? Don't we use V equal to ED for capacitor? So if you think of it like I explained earlier, જો વિચારવા માટે કઈ પ્રોબ્લેમ નથી. બોર્ડ વાળાને નાની પડે આવડે વિચારવાનું. હવે લખવાનું ને એમ. Understood? This one, this is a capacitor. What is the electric field in the first part? E0 by K. And how much is the distance? 3D by 4. So એનો વોલ્ટેજ એટલા હોય કે નહીં? Plus. હવે શું એડ કરવાનું? Second one, E0 D by 4. Clear or not clear?
Yes.
Why? Because here K is equal to 1. We have got V. Okay. And let's take the LCM and all that and whatever is common. So E0 D is common. By 4 also common. Okay. Then 3 plus K by K. Got it? This is V. Now what would be E0 into D? Suppose you don't put anything here. What would be E0 into D? V0. Yes or no?
Yes.
Sure, everyone got that?
Yes.
Or not clear? If you don't have anything between plates, all air, then E0 into D would be the voltage of the original capacitor. Correct or not correct?
Yes.
Why is voltage changing but charge not changing? Because we are assuming that what? Battery has been disconnected. બીજી રીતે કરો તો આન્સર આવે પણ મેથડ આખી અલગ થઈ છે. Right? So E0 into D is V0 and 3 plus K upon 4K. What is V0 here? Please write where V0 is the voltage of capacitor before inserting slab or sheet જે લખ્યું હોય પેટર્નમાં લખો. Now, we know charge is not going to change. આપણે એ રીતે કરીએ ને. બસ આવી ગયું. હવે ડિવાઇડ કરી નાખો એટલે C equal to Q by V0 Q by V. But Q is going to be same as Q0. Why same as Q0? We are assuming we are considering a case where battery has been removed. Okay, so Q is Q0. Instead of V, what should I write? V0 3 plus K and 4K will come to numerator. Okay, what is Q0 by V0? C0. Yes or no? Okay, 4C0K divided by 3 plus K. Clear? So this was by basics again. Let me be clear. This line is the main thing in this solution. આના પછી તો સિમ્પલ જ છે. એકવાર ઈ આવડી જાય કે કે simple idea to find voltage. We can take help of electric field. Yes, electric field and voltage always have a relation. બરાબર? ગમે તે સમયમાં relation તો હોય જ બે વચ્ચે. So that's what we use. Here we use that which I told you, be careful. V equal to ED. બધે ન કરવા મળતા. એક બે સમમાં આવ્યું તો સર V equal to ED. બધે કરીએ છે હવે. No. Okay, you have to use it very carefully. Guru, Ajit to back. Okay. The time is about to.